Picture this: a darkened forge in the dead of night, somewhere along the winding banks of the Tagus River. The only light comes from a mound of glowing charcoal, and standing before it, slick with sweat and soot, a man raises a hammer above a bar of incandescent metal. The steel is white hot, so bright it hurts to look at, and the smith strikes it once, twice, 3 times. Sparks scatter across the stone floor like a constellation brought to earth. Each blow reshapes the metal, compresses its grain, forces out the impurities hiding inside. That bar of raw steel will become something feared across 3 continents. A blade from Toledo, Spain, a city whose very name, for centuries, was synonymous with the most lethal and beautiful swords the world had ever seen. What made Toledo blades different from every other weapon forged in medieval Europe was not merely the skill of the men who made them. It was a convergence of geography, chemistry, secrecy, and centuries of accumulated knowledge, passed from master to apprentice in workshops that outsiders were forbidden to enter. This is the story of how those blades were born, from raw steel ingot to finished weapon, and of the men whose hands and eyes performed what others called sorcery. Long before the first Christian king reclaimed Toledo from Moorish rule, the Iberian Peninsula was already a land steeped in metalworking tradition. The geological wealth of the Toledo region, with its high-purity iron deposits and proximity to the Tagus River, provided ideal natural conditions for steelmaking. Iron ore from the surrounding hills contained fewer impurities than deposits found elsewhere in Europe, and the water of the Tagus, cool, mineral-rich, flowing at a steady current year-round, offered something no other European river could replicate: the perfect quenching medium. The Romans recognized this. They established forges here as early as the 2nd century before Christ, and when the Visigoths came, they inherited those forges. When the Moors conquered the peninsula, they brought with them the sophisticated metallurgy of the Islamic world, knowledge of crucible steel, of pattern welding, of controlled carbon content, and merged it with what already existed on the banks of the Tagus. By the time of the Reconquista, when Christian forces gradually reclaimed Iberia over the course of several centuries, Toledo had become something more than a city with forges. It was a living laboratory of blade science. The Muslim and Christian traditions of metalwork collided and fused here, producing techniques that neither culture could have developed alone. The 2 legendary swords of El Cid himself, Tizona and Colada, were forged in Toledo, and their fame only deepened the mystique surrounding the city's workshops. So how did it all begin? With the steel itself. The journey of every Toledo blade started not at the anvil, but in the selection of raw material. A master swordsmith, an espadero, would examine each ingot of steel with the scrutiny of a jeweler inspecting a gemstone. He would study its color, its weight, its surface texture. He would sometimes strike it against the anvil and listen. An experienced ear could detect the carbon content of steel by its ring. A high, clear tone suggested good carbon distribution. A dull thud meant the metal was too soft, too full of slag. The steel used in Toledo blades was a high-carbon alloy, typically containing enough carbon to achieve exceptional hardness, while retaining the capacity for flexibility once properly treated. This balance, hardness without brittleness, sharpness without fragility, was the holy grail of medieval bladesmithing, and Toledo's masters pursued it with an almost religious devotion. Once a suitable ingot was selected, it was placed into the forge. Toledo's forges burned charcoal, not coal, which would have introduced sulfur and other contaminants into the metal. The charcoal was heaped around and over the steel, and bellows were pumped to raise the temperature. In the best workshops, the bellows were operated by apprentices who had to maintain a steady, rhythmic airflow for hours at a time. The forge needed to reach temperatures approaching 1000 degrees Celsius, hot enough to make the steel malleable without melting it entirely. At this heat, the metal glowed white, and the smith had a narrow window in which to work before the temperature dropped. The forging itself was brutal, precise labor. The smith used heavy hammers to draw out the ingot, elongating it into a rough blade shape. Each hammer blow did more than shape the exterior. It compressed the internal grain structure of the steel, aligning the crystalline lattice and driving out microscopic pockets of gas and slag. This process, repeated through multiple heating and hammering cycles, is what gave a hand-forged blade its superior strength compared to cast metal. A Toledo smith might reheat and hammer a single blade dozens of times over the course of several days, and at each stage he would examine the metal's behavior, how it moved under the hammer, how it responded to bending, how its color shifted as it cooled. But the true secret of Toledo steel, the technique that set it apart from blades made in Solingen, Passau, Milan, or anywhere else, was a construction method known poetically as the soul of iron. The Toledo technique consisted of forging a steel blade that enveloped a wrought iron strip running through its core. Steel, with its higher carbon content, provided the hard cutting edge that could slice through mail and leather. But pure steel, when hardened, becomes brittle. Strike it against a stone wall or another blade, and it could snap. Wrought iron, by contrast, is soft and flexible, but cannot hold a sharp edge. By combining the two, steel on the outside, iron on the inside, Toledo smiths created a blade that was simultaneously hard and resilient. The steel edge cut, the iron soul absorbed shock. It was engineering of extraordinary sophistication for an age that had no microscopes, no metallurgical textbooks, no understanding of crystallography. It was knowledge gained entirely through centuries of empirical observation, passed in whispers from master to apprentice. This layered construction required extraordinary skill. The iron core and the steel outer layers had to be forge welded together at precise temperatures. Too cool, and the metals would not bond. Too hot, and the carbon in the steel would migrate into the iron, ruining the differential properties that made the technique worthwhile. The smith had to judge temperature entirely by color, the shift from dark cherry red to bright orange to yellow to white. Every shade corresponded to a temperature range, and the experienced espadero could read these colors the way a musician reads notes on a page. Once the blade was forged to its rough shape, it entered the most critical and dramatic phase of its creation, the tempering. This was the moment that separated a mediocre blade from a masterpiece, and it was here that the Tagus River played its legendary role. The smith would heat the blade once more to incandescence, to around 800 degrees Celsius, judging the temperature by the blue-violet hue of the glowing metal. Then, in a moment that witnesses described as almost ceremonial, the blade was plunged into the waters of the Tagus. Some accounts say the exact duration of immersion was measured not by clocks or hourglasses, but by the recitation of prayers or ancient verses. The smith would murmur the words, and when the prayer was done, the blade was withdrawn. This was not mere superstition. The length of the prayer corresponded to a precise cooling time that the smiths had calibrated over generations. The mineral content and temperature of the Tagus water produced a rate of cooling that was neither too rapid nor too slow, fast enough to harden the steel, gentle enough to avoid the microfractures that plagued blades quenched in plain cold water. After quenching came a secondary tempering, a controlled reheating to a much lower temperature, around 200 to 300 degrees Celsius. This step relieved the internal stresses that quenching had introduced into the metal's crystalline structure. The blade was held at this lower heat until its surface turned a telltale bluish color, a visual signal that the steel had reached the optimal balance between hardness and toughness. Without this secondary tempering, the blade would be glass-hard, but dangerously brittle. With it, the sword could hold a razor edge and still flex under impact without shattering. This combination of quenching and tempering gave Toledo blades their near-mythical reputation, swords that could cut through lesser weapons and bend nearly double without breaking. With the metallurgy complete, the blade moved to the grinding and polishing stages. Grinding wheels, often powered by the flow of the Tagus itself through watermill mechanisms, were used to establish the blade's final geometry, its taper, its edge bevel, its fuller or central groove, which reduced weight without sacrificing rigidity. The smith or a specialized grinder would work the blade against the stone, periodically cooling it with water to prevent the friction heat from undoing the careful tempering. A finished Toledo blade typically featured a broad, double-edged design with a ricasso, an unsharpened section near the hilt, where the swordsman could choke up his grip for greater control, and 3 grooves running along each flat nearly to the point. The final stages involved fitting the blade with its hilt, guard, and pommel, though in many cases, the blade and hilt were made in entirely different workshops, sometimes in entirely different countries. Sword blades were articles of international trade, made in a few important centers and shipped all over Europe, where they were fitted with hilts in the local fashion. A Toledo blade might travel to Dresden, to Paris, to London, to be married with a hilt forged by a German or French artisan. During the 16th and 17th centuries, the sword blades of Toledo, Valencia, and Milan were the most sought after in Europe, although the largest center of production by volume was the German town of Solingen. But it was the Toledo name that carried the greatest prestige. The finest European hilts were usually equipped with a Spanish blade. If a Toledo blade was not available, a German one, sometimes bearing a spurious Spanish inscription to increase its perceived value, was fitted instead. The men who made these blades did not work in isolation. They were part of a tightly regulated ecosystem of craftsmen centered on a street called the Calle de Armas, Weapon Street, where the most prosperous sword makers maintained their workshops alongside ironsmiths, crossbow makers, and knife and axe makers. The guild system governing Toledo's sword makers was among the strictest in Europe. Those seeking to practice as espaderos had to pass rigorous tests of quality stipulated by the king himself. A young man entering the trade would begin as an apprentice, taken on by a master at a young age. Advancement from apprentice to master was by no means guaranteed and rested entirely upon being noticed as a talented worker likely to be worthy of patronage or capable of securing loans. Masters were unlikely to be lenient toward their apprentices, as only the master would suffer financially from inferior workmanship. The system was designed both to forge the best possible craftsmen and to regulate the number of workers, reducing competition and preserving the prestige of the trade. This guild structure mirrored, in fascinating ways, the feudal hierarchy that governed the rest of medieval society. The parallels between a smith rising through the ranks and a young knight seeking recognition were noted even by contemporaries. Both required years of dedicated service, both depended on the favor of a superior, and both culminated in a form of investiture. The knight received his spurs, the smith received his master's mark, and that mark was everything. Each master swordmaker in Toledo stamped his blades with a personal mark, a symbol, a monogram, an emblem that served as both signature and guarantee of quality. The most famous makers, like Miguel Cantero and Alonso Perez, who worked at the shop of the celebrated Gil de Almao, producing swords for Emperor Charles V and his son Philip II, left marks that were recognized across Europe. To forge a blade bearing a false Toledo mark was a crime, and in 1567, King Philip II issued a royal decree explicitly forbidding the importation of foreign swords into Spain and mandating that all Toledo blades bear the mark and signal of the master, who made them and the place where they were manufactured. Violators were to be condemned as forgers. This royal protection was not merely economic, It was a recognition that Toledo's blades were a strategic national asset. In an age when the sword was the primary sidearm of every soldier, nobleman and gentleman, the quality of one's blade could mean the difference between life and death. Toledo steel was not simply better craftsmanship, it was a military advantage. Kings, conquerors and knights across Europe longed to wield these legendary blades, and the Spanish crown understood that controlling the supply of the world's finest swords was a form of power in itself. The daily reality of the workshop, however, was far removed from the romance of royal courts and battlefield glory. The forge was brutally hot, the labor exhausting, the hours punishingly long. Apprentices worked from before dawn until well after dark, maintaining the fires, pumping the bellows, fetching water and charcoal, and gradually, if they proved worthy, being allowed to assist with the simpler stages of forging. A capitulary from 802 had already stipulated that lords must have smiths available to produce chainmail for military campaigns, establishing the smith's obligation to serve both commerce and war. By the high medieval period, blacksmiths and bladesmiths occupied a peculiar dual role in society. They were artisans and tradesmen, but they were also, in a latent sense, military assets who could be called upon to arm the state at any moment. The sound of the Calle de Armas must have been extraordinary. A constant percussion of hammers on anvils, the hiss of quenched metal, the roar of bellows, the grinding of stone on steel. Smoke rose from a dozen chimneys. The smell of burning charcoal mixed with the sharp metallic tang of worked iron. Merchants from across Europe walked this street, examining blades, haggling over prices, arranging shipments to distant courts. The swords that left Toledo's workshops ended up in the hands of Spanish conquistadors crossing the Atlantic, of French knights riding to war in Italy, of German princes presiding over tournaments, of English gentlemen dueling at dawn. The peak of Toledo's production came in the 15th and 16th centuries, when the city was considered the greatest sword-making center in the world. By the end of the Reconquista, with the Iberian Peninsula fully unified under Christian rule, Toledo's workshops operated at a scale and level of quality that few could rival. While Solingen and Passau in Germany may have matched Toledo in production volume, they could not match its reputation. A Toledo blade was not merely a weapon, it was a statement of status, a work of art, and a piece of engineering that represented the pinnacle of what human hands could achieve with fire and steel. But nothing endures unchanged. As firearms gradually replaced swords on the battlefield, the demand for hand-forged blades began its long, slow decline. The great workshops of the Calle de Armas fell quiet, one by one. Masters died without training successors. Techniques that had taken centuries to develop were lost in a single generation. In 1761, King Charles III attempted to preserve what remained by founding the Royal Sword Factory of Toledo, the Real Fábrica de Espadas, gathering the finest remaining master swordsmiths under one roof and modernizing production to meet contemporary military needs for sabers, bayonets, and ceremonial weapons. Yet even that royal intervention could not hold back the tide of industrialization. The age of the hand-forged blade was ending. Where once hundreds of master espaderos had worked the Calle de Armas, by the 21st century, only 2 artisan workshops remained in all of Toledo. The last 2 places on earth where swords are still made by hand, using techniques that stretch back more than 2 millennia. One of them belongs to Mariano Zamorano, a 4th-generation master swordmaker, who has spoken openly about practicing a craft that stands on the edge of extinction. Stand in his workshop today, and you will see the same tools, hear the same sounds, feel the same heat that a visitor to the Calle de Armas would have experienced 500 years ago. The charcoal forge still glows. The hammer still rings against the anvil. The blade still plunges into its quenching bath with that violent singing hiss. And in that moment, in that ancient collision of fire and water, of carbon and iron, of human skill and elemental force, the soul of Toledo lives on. Word count, approximately 2,650 words. Let me extend this narration to meet the 3,500-word target. The steel emerging from that quenching bath, still steaming, still too hot to touch, was not yet a sword. It was a promise. And fulfilling that promise required a level of patience that is almost impossible to convey to a modern audience accustomed to machine production. After the secondary tempering turned the blade that distinctive bluish hue, the espadero would set the weapon aside and inspect it one final time under natural light, turning it slowly, sighting down its length, the way a carpenter sights down a plank of wood. He was looking for warps, even a slight curve, invisible to an untrained eye, could throw off the blade's balance and compromise its performance in combat. If a warp was detected, the smith would make minute corrections, applying carefully controlled pressure or gentle heat to coax the metal back into true alignment. This stage could not be rushed. A blade that left the workshop imperfect brought shame not only on the individual smith, but on the entire guild. The grinding and finishing of a Toledo blade was itself a specialized art. Not every swordmaker performed this step personally. In many workshops, dedicated grinders and polishers, men who had spent years mastering the geometry of edges and the art of working abrasive stone, handled this phase. The blade was held against a grinding wheel, its angle adjusted with a precision born of long practice. The fuller, that central channel running along the flat of the blade, sometimes incorrectly called a blood groove, was not decorative. It reduced the blade's weight while maintaining its structural rigidity, the same engineering principle that modern architects use when designing I-beams. Carving this groove to a uniform depth and width, without overheating the tempered steel beneath, required a steady hand and absolute concentration. After grinding came polishing, a process that moved through progressively finer abrasives until the blade shone like a mirror. This was not vanity. A highly polished surface resisted corrosion better than a rough one, an important consideration for a weapon that might spend months at sea in the hold of a ship, crossing the Atlantic to the colonies or the Mediterranean to Naples. The polish also allowed the owner, or the king's inspectors, to examine the blade's surface for inclusions, cracks, or other defects that rougher finishes might conceal. Then came the marking. The master would take his punches, small steel dies bearing his personal emblem, and strike them into the ricasso, that unsharpened section of blade near the hilt. On either side of the ricasso, the stamps were pressed with deliberate force, permanently branding the blade with its maker's identity and its place of origin. Some masters added inscriptions as well, mottos in Latin or Spanish, invocations of divine protection, or the name of the patron who had commissioned the weapon. The sword signed by Miguel Cantero in the Victoria and Albert Museum bears his name on one side, and the motto, En solo Dio confio, in God alone I trust, on the other, a reminder that these were weapons made by devout men who believed that their craft served a purpose higher than commerce. The commercial reality of Toledo's blade trade was nonetheless formidable. Because the finest blades were recognized across Europe, they commanded prices that reflected their quality and scarcity. A single Toledo blade could cost as much as a common laborer might earn in several months. The economics of the trade created a thriving international market in which blades were shipped as semi-finished goods, naked steel without hilts, to be completed by local artisans in the buyer's home country. This system meant that a gentleman in Saxony might carry a sword whose blade was forged on the banks of the Tagus, but whose hilt was crafted in Dresden, its silver ornament depicting Germanic dancing figures and grotesque masks in the Northern European style. The sword was, in this sense, a truly international object, a collaboration across borders and cultures, united by the universal respect for Toledo steel. The trade also created economic incentives for fraud. Because a Toledo mark added enormous value to a blade, unscrupulous smiths in other cities began forging false marks and inscriptions. The practice became so widespread that it provoked royal intervention. Philip II's decree of 1567 was specifically designed to combat this counterfeiting, threatening those who used false marks with prosecution. The problem of spurious Toledo marks persisted for centuries nonetheless. Even today, museum curators examining historical swords must carefully distinguish genuine Toledo blades from German or Italian imitations bearing fraudulent Spanish stamps. Within the city itself, the concentration of metalworking crafts along the Calle de Armas created an ecosystem of interdependent trades. The espaderos depended on ironsmiths for raw material, on charcoal burners for fuel, on tanners for the leather used in scabbards and grips, on woodworkers for the wooden cores of those same grips, and on engravers and gilders for the decorative work that turned a functional weapon into a work of art. Crossbow makers and knife makers shared the same street and often the same suppliers. The guild system regulated not just who could practice each trade, but the quality and sourcing of materials, ensuring that substandard iron or improperly seasoned charcoal never entered the production chain. It was, in modern terms, a vertically integrated supply chain governed by quality control standards enforced by royal authority. The human cost of this excellence was considerable. Working in a medieval forge was dangerous. Burns were routine. The constant exposure to extreme heat, metal dust, and smoke took a toll on the lungs and eyes. The rhythmic heavy hammering damaged joints and tendons. Few smiths worked into old age with their bodies intact. And yet the trade attracted generation after generation of young men, drawn by the promise of mastery, of independence, of the respect that a master espadero commanded in Toledo's social hierarchy. To be a master swordmaker in Toledo was to occupy a position of honor. Not nobility, certainly, but a recognized and valued place in the community, protected by royal decree and guild regulation alike. The blades these men produced were tested as rigorously as they were made. Guild regulations required finished swords to be subjected to specific quality tests before they could receive the master's mark and be offered for sale. These tests typically involved bending the blade to extreme angles to verify its flexibility and then checking that it returned to true, as well as striking it against hard surfaces to confirm that the edge held without chipping. A blade that failed these tests was broken and discarded. There was no secondary market for substandard Toledo steel. The guild's reputation, and by extension the city's economy, depended on absolute consistency of quality. It is this uncompromising standard, maintained across centuries and through the rise and fall of empires, that gives the story of Toledo steel its enduring power. These were not just weapons. They were the product of a civilization's accumulated genius, the Romans' engineering, the Visigoths' metallurgical inheritance, the Moors' crucible steel techniques, the Christian guild's organizational discipline, and the Tagus River's irreplaceable chemistry, all converging in workshops where the glow of the forge never fully died. Every blade that left the Calle de Armas carried within it the soul of iron and the fire of 1,000 years.